Welcome to the first module in the Food Zoomers training under the Vibrant Functional Academy. In this module, we are going to go over a basic overview of immunoglobulins. Primarily, we're looking at IgG and IgA, as well as the various types of immune responses. We'll dive into a discussion about proteins and peptides and why that's important to understand before interpreting these tests. And then we'll walk through lectin zoomer and dairy zoomer as far as important points to know about the test and interpretation. Okay, so before we get into the tests themselves, there is some background information that's pretty critical to understanding the test results, why you should use these tests, where you would use them, and what to do with the results. The first thing to know is that immune-mediated reactions are hypersensitivities of one form or another, and they involve a foreign protein, which could be food, or it could also be bacteria, viruses, endotoxins, and so forth. They are going to involve the presence of one or more types of immunoglobulins. A type 1 hypersensitivity is an allergic reaction. So this is what we tend to think of when we see anaphylaxis. That would obviously be the most severe or life-threatening side effect of an allergic reaction, but you could also have more milder reactions such as burning or itching in the mouth, hives, skin rashes, and so forth. Type 2, 3, and 4 are all non-allergic hypersensitivities, and these involve either chemical mediators such as cytokines or antibodies, which are your immunoglobulins of various types, with the exception of immunoglobulin E, since that is the one involved in type 1 hypersensitivities. Now, there's also non-immune mediated reactions that could happen to food, and that's what food intolerances are. So this would be something like lactose intolerance or a bile salt deficiency that impairs fat digestion and absorption. These three terms, allergy, sensitivity, and intolerance, are often mistakenly used interchangeably, but are all three completely different types of reactions to foods. So it's very important to know exactly what you're talking about. If you're talking about an allergic reaction to a food, you're talking about IgE, which is not the food zoomers, with the exception of wheat zoomer, contains your IgE to wheat. But when you're talking about food allergies, typically that's not the food zoomers that you're looking at. Now, if you're talking about sensitivities, the food zoomers are the tests that you're going to be discussing there. If you're talking about intolerances, there's really not a great way to actually test for intolerances because there's no immune-mediated molecule or compound or immunoglobulin that you're going to test for. There's no immune response involved in an intolerance. It's most common to use the terms sensitivity and intolerance interchangeably in the lay public. However, they are completely different things, and it's really important to know that before jumping into this type of testing. Okay, so another way to think about this is type 1, type 3, and type 4 are the forms that are going to involve immune cells. Antibodies are going to be specific to each type of foreign substance. So the antibodies that you make to one thing typically do not bind to another thing unless they have a very, very high degree of homology, which means their chemical protein structures are so incredibly similar that they are essentially recognized as the same thing. But we'll go on as we walk through some of these and we start talking about peptides. We basically minimize or eliminate that cross-reactivity that happens by looking at peptides in these proteins. So, as far as type 1 hypersensitivities, again, that's our allergic reactions. Those are going to be mast cell driven. Type 3 and type 4 are your immunoglobulins, as well as your T cells. So T cells are going to be your cytokine. The type 3 are the ones that we're focusing on here with the food zoomers. So these are going to involve your immunoglobulin G, M, and A. To a certain extent, we're really not looking at IgM on the food zoomers. That's more relevant to things like infections and then neurological testing. So when we talk about Neural Zoomer Plus, you will see IgM on that test. So type 3 hypersensitivities, the mechanism is that an antigen, which is simply just a foreign protein, presents and is recognized as foreign or a threat. So it is not self. What that means is that the immune system in the human body recognizes all proteins or proteins on cell walls in all of the cells in the body, including the ones that don't belong to us, right? They might belong to our microbes. And as soon as it sees something that is not us, it is then classified as foreign or a threat, depending on what it is. Antibodies in the form of IgG, IgM, or IgA, depending on what's happening and where the location in the body is, bind to the antigen to neutralize it or keep it from binding anywhere else in the body, and this forms an immune complex. Immune complexes can insert themselves into other places in the body, such as small blood vessels, joints, tissues, glomeruli in the kidney, and this is what causes symptoms. Typically, that's what happens with IgG or IgM. IgA doesn't really do that. IgA is actually classified as a non-inflammatory antibody, and we'll get to that in just a little bit what that means. They're also far more capable of interacting with complement proteins to form medium-sized complexes, which, when you have an excess of the antigen, the original foreign protein, can be highly pathogenic. Once in the tissues, and remember, keep in mind this is primarily IgG that does this, but some IgM as well. These new immune complexes are often able to induce inflammatory responses, causing tissue damage. So they cause the immune system to head to that point of where they've inserted themselves. And the immune system then begins to attack not just the immune complex or the inflammatory foreign protein, but also its own tissues. This damage is a result of cleaving complement anaphylotoxins, and that gets into another discussion that's kind of beyond the scope of this, but this is sort of just the mechanism behind the systemic inflammation that results from hypersensitivities. And then basically inflammatory cells are recruited into the tissue to try to deal with the problem and try to basically break up and get rid of the inflammation. But this also leads to further tissue damage through phagocytosis, which is basically just the cells, certain immune cells eating or trying to eat or ingest other cells or compounds that are inflammatory. So with IgA antibodies, it's important to understand the difference between IgA and IgG because you will see both on these tests. IgA antibodies are found in the areas of the body that are basically mucosal membranes, so breathing passages in the lungs and the esophagus, digestive tract, ears, eyes, and the lining of the vagina. They participate in mucosal immunity, so of course these surfaces are surfaces that are in contact with the outside world, more so than with the interior of the body. So think of all of those surfaces as places where environmental toxins are more likely to come in contact, ingested foods or proteins, etc., can come in contact, or other foreign substances are more likely to come in contact with those surfaces. There's more IgA produced in the mucosal linings than all other types of antibodies combined. So that is the predominant source of antibody there. IgA antibodies protect these body surfaces that are exposed to the outside foreign substances. So their job is basically to act as a barrier or a preventive factor to keep anything from binding to these cells that line those mucosal surfaces. In the gut, specifically, they bind to the mucus layer on top of the epithelial cells to form a barrier capable of neutralizing threats before they reach the cell. IgA antibodies are considered non-inflammatory, meaning that they do not stimulate inflammatory processes in the body the way that IgG does. They are created in response to a foreign antigen, usually microbial, such as the bacteria or viruses, et cetera, that live in our gut, or those microbial toxins. They're also part of a very complex communication network that happens between the host's immune system and the commensal bacteria that live in the gut. They're a mechanism that helps to control the populations of helpful commensal bacteria, as well as prevent colonization by pathogenic or opportunistic bacteria. They can be generated in response to pollutants and toxins, and they may also be generated in response to foods which are undigested and recognized as foreign proteins. In the intestinal lumen, they are indicative of immune response stimulated by a T cell to B cell interaction. We don't go in super depth about this in this set of modules. However, we do discuss that in the wheat zoomer modules. So if you have not already watched the wheat zoomer modules, I would encourage you to go back and watch those to understand the complexities of T cell to B cell interaction and what exactly is happening there before going into this concept of IgA antibodies. In short, healing interventions probably need to focus on targeting Th1 and Th2 immune balance and upregulating Treg production. Of course, your Tregs, again, if you have not watched those wheat zoomer modules, your Tregs are your critical immune balancing cells in that sort of adaptive immunity, and they are sort of the police of the immune system. They help to reduce autoimmune and reduce inflammatory responses that are not normal. IgG antibodies are found throughout the body. They're the most numerous. They make up probably 75 to 80% of all the antibodies found in the human body. They're very important for fighting infections like bacterial and viral infections. They're also the only type of antibody that crosses the placenta, so a good deal of immunity in utero for newborns is actually formed in utero based on their mother's immune responses. So keep that in mind with pregnant populations. If there are aberrant immune responses, especially things like food sensitivities, these antibodies are able to cross the placenta and may translate into greater risk for those types of sensitivities or health conditions later on in life for a child. They do indicate exposure to a specific antigen, but they do not necessarily always indicate active inflammation. However, it may contribute to it, and it may be dose dependent. So why would we measure IgA and IgG on these foods? Some people do not produce much or any IgA antibodies. There is such a thing as an IgA deficiency. And that's why there's also an option when ordering any of the food zoomers, there's an option on the requisition to order the total immunoglobulin panel, which is very important to do that. If you're not doing it, I strongly encourage you to do so. It gives you some background as far as how to interpret these tests. If you have a patient who has an IgA deficiency, or even, less commonly an IgG deficiency, but it would affect the test a little bit more greatly if they did. If these immunoglobulins are deficient or they tend to run kind of subclinically low, the immunoglobulin levels on their tests will reflect that, meaning that they will show little to no reactivity to foods tested if they don't have a great enough pool of these total immunoglobulins available in which to form an immune response. Measuring IgA specifically, again, some IgG antibodies are not really an indicator of actual inflammation or disease process. They may simply be formed in response to a protein being presented to the immune system or present in the body, simply just tracking it to say, okay, this is here, but it didn't necessarily elicit a reaction. There was no complement binding involved, and it's not inserting itself into tissue sites, etc. So IgG and IgA testing at the protein level, this is specific IgG or IgA to a whole protein or extract level of a food. The strengths of it are that you can accurately measure IgG or IgA to a specific food protein. It can be good for associating type 3 reactions involving IgG or IgA complexes. If IgG is pathogenic, this will be useful. So in situations where individuals have systemic inflammatory processes that are directly related to the exposure of the whole food protein to the immune system, this is useful. A weakness of this type of testing, and again, when we're talking about at the protein level, this is food sensitivity testing. So this is not food zoomers. This would be Vibrant's food sensitivity testing and all other labs that run food sensitivity testing. They are testing the whole protein of a food. this, again, IgG can be a protective antibody, and a high amount of it may be a good thing or simply may be neutral. It may not be actually inflammatory. IgG and IgA antibodies represent whole proteins being presented to the immune system, which can also be an indicator that a patient lacks sufficient digestive capacity when many sensitivities are detected. And we'll get into that in a little bit more detail. When we're testing at the peptide level, so this is the food zoomers, what's happening is there's a high level of antibody specificity. Cross-reactivity is minimized or eliminated. So what we're doing is antibodies to individual peptides in cow's milk will not bind to whole cow's milk protein and vice versa. This kind of picture or graphic here demonstrates the shape of antibody to antigen recognition, how specific it is. An antibody, so for instance, the antibody on the left may be an antibody to beta casein, and the antibody on the right may be an antibody to whey protein. And you can see how antibodies to whey protein would not recognize casein and vice versa. Therefore, if one consumed only casein, only antibodies to casein would be formed and not to whey. And that's how peptides work. Another concept to understand in this whole discussion is loss of oral tolerance. This basically just describes the phenomenon of developing a sensitivity, whether or not it's accompanied by symptoms, to a commonly consumed food and the production of inflammatory cytokines and or antibodies in response to continued exposure to the food. Generally what this means is I generate antibodies to a food that I eat. Sometimes I know because when I eat the food there is a symptom that's unpleasant, such as gastrointestinal distress, a headache, fatigue, skin rashes, and so forth. And then sometimes I may not notice that I generate inflammation. And it could simply be because it is kind of silent inflammation, meaning that there's not a really obvious symptom. Or it might be, if I'm a patient, especially if I'm really not that in tune with my body and I'm not paying that much attention to what's going on, there may be some side effects and symptoms that are occurring. I'm simply not associating the symptoms with the food because perhaps they happen 24 hours later or something like that. Loss of oral tolerance typically requires elimination of the offending foods for 3 to 4 weeks if it's an IgA-associated sensitivity, or up to 3 to 6 months if it's IgG, and this is going to vary by person, for antibodies to disappear. Now, disappearance of antibodies does not necessarily guarantee that oral tolerance has been reestablished. This is what's important. A large part of this involves the barrier permeability of the intestinal barrier. Again, if you haven't watched the Wheat Zoomer modules, we go into detail about intestinal barrier permeability, and I strongly encourage you to go back to review that to understand this concept. If the intestinal barrier is not intact and you eliminate a food, you do reduce the immune response to it, and antibodies will disappear if it has not been consumed. But those antibodies going away doesn't mean that you can then eat the food again. It largely relies to a great degree on whether or not the intestinal barrier has been healed and sealed. If the immune system has basically calmed down and decided that this food is no longer a problem. Okay, so let's get into this discussion of proteins and peptides to really thoroughly understand exactly what the food zoomer tests are looking at. So in this picture, we have the primary, secondary, tertiary, and quaternary structures of a protein. What that means is that every single protein in nature, think about everything that makes up humans, from head to toe, our hair, skin, nails, cells, eyes, organs, blood, etc. Absolutely every structure in our body has protein involved in some way, and in nature as well. So we're talking about plants, animals, bacteria, and so forth. All proteins start out here on the left-hand side, where you have these chains of amino acids, and basically think of them like a string of pearls. And these chains of amino acids are simply just individual amino acids linked together, And then because of the conformation or the order in which those amino acids are linked together, it will then form a secondary shape, which could be, for instance, a helix, which is what you see there in the middle, or it could be a sheet, depending on how the amino acids line up and how they grab, how the side chains on the amino acids grab each other to form shapes. Now, from there, these helices or sheets can then form a tertiary structure, which means the protein, let's say you have a helix, you have basically a long, twisted, curly-Q type of ribbon shape. Now that, because of the order of the amino acids, the way that it has bonded, can then further fold in on itself, and you see there in the picture at the top right corner there, in that far top right corner, that's what that would look like, is if these helices were then folding in on themselves to form more of a kind of loose, globby looking protein. That then forms a quaternary structure with other proteins into one big, larger, globular looking shape, okay? Now, where we are testing with the peptide level food zoomers is over here on the left. We have taken this big, large quaternary structure, whole protein, flattened it all out, sequenced the entire proteome of it so that we have essentially what's over here on the left side. We have made this for each of the food zoomers that we are testing. So we've taken the entire proteome of wheat, all of the species of seafood, nuts, soy, corn, and so forth. And we've created the big, long chain of amino acids. And then from that chain of amino acids, we're looking at individual little snippets of it. So what you're getting with the food zoomers is absolutely the entire thing, whatever the food that's being tested, every possible combination of amino acids in it that could be presented to your immune system during and after digestion. What you get with food sensitivity testing is basically just the entire whole protein in that form, and because it's extract technically, which means it includes the whole protein, but it's got little bits and pieces of other things. So there might be a little bit of carbohydrate residue, there might be residues from other things in there, and that's what whole protein food sensitivity testing is. What you're getting is basically what the whole protein form of that is, but not the individual peptides within it. So this is another way of looking at this. Let's pretend that this big globular looking protein, this is whole cow milk dairy protein. And perhaps this red protein here on the side, technically it's bigger than a peptide, but this whole protein here on the side is beta casein. You could make antibodies to this entire big globular shape that would be to the whole protein, and those antibodies would not be the same as antibodies to beta casein, the red globular looking protein on the right, because they're not the same shape. You can clearly see that these two things are two distinctly different proteins, and the antibodies to them would be completely different. Therefore, antibodies to whole cow's milk protein would simply indicate that whole cow's milk protein is being presented to your immune system undigested, and that's what you're forming antibodies to. Whereas antibodies to beta casein would mean that beta casein is being presented to your immune system, but that whole cow's milk protein may not be a problem. However, because beta casein is a part of whole cow's milk protein, you would not want to consume whole cow's milk protein. So here's the limitation of this whole protein testing. Remember, this is food sensitivities, like the 96 food sensitivity or any of the other food sensitivity testing you're running from other labs. We're assuming that the gut barrier is intact and functional, so there's no leaky gut present. And we're also assuming that hydrochloric acid and digestive enzyme sufficiency is adequate for proteolysis, which means essentially we're breaking down proteins in the stomach in the hydrochloric acid, and then once they transit into the small intestine, we have sufficient enough digestive enzymes to continue to hydrolyze those bonds and break them into peptides where they can then be absorbed. Now, you can see where there's some flaw in this line of thinking, however, especially in the functional world. You're seeing patients with digestive problems a lot. They're probably making up the majority of the patients in your practice. They have some sort of GI inflammation or problem with inflammatory conditions and symptoms. These patients commonly have hypochlorhydria and deficiencies of enzymes or bile acid. If it's not an overt deficiency, a lot of times they have some imbalance where possibly they don't have enough enzyme to balance out the hydrochloric acid, or sometimes when the pH is not adequate. For instance, they might have hyperchlorhydria and the pH is actually very, very low, and if there's not enough bile to neutralize that in the small intestine, the pH is incorrect in the small intestine, and enzymes only function at a certain pH range. So for instance, if you have too much acid and not enough bile to neutralize it, your digestive enzymes may be basically dysfunctional because it's too acidic for those enzymes to operate. That's just one example. Most of these patients also have moderate to severe impairment of the intestinal barrier. So when you have this situation, which is probably, 9 times out of 10 or greater when you're talking about a functional medicine practice, whole protein food sensitivity testing then basically just becomes a food intake record, which is just telling you these are the foods this patient has been eating. Not necessarily that these are the foods they're sensitive to, it's just these are the foods this patient is eating because they're not breaking them down, they're not digesting them fully, and this is really just suggestive of barrier permeability and maybe even an indirect indication of low stomach acid. Okay, so then now that we've kind of talked about, again, what that whole protein food sensitivity testing is looking at, let's go back to the peptide level testing, which is what the food zoomers are looking at. The strengths of this are that the reproducibility is higher. Vibrant actually in our portal, you can pull up under the resources tab our reproducibility reports for these tests, and we can show that over a course of, depending on the test, it will be 3 to 5 days, we can run the exact same sample multiple times a day and get the exact same result. I'm not aware of any other laboratory that publishes their reproducibility reports, but that is something that Vibrant values very highly, is the ability to run the exact same sample and always get the same results, which in the lab world should be the gold standard. Again, I don't really know of any other labs that do that. It does not rely on the sufficiency of hydrochloric acid or enzymes. You should have peptides in the small intestine, and that's what should be found there because that's what's absorbed. Or those peptides are even then further broken down into individual amino acids. So whether or not you have hydrochloric acid or enzyme sufficiency or deficiency is not going to affect peptide level testing. Cross-reactivity is eliminated because, again, when we're talking about peptides, we're talking about something that is typically 20 or fewer amino acids bonded together. So you're not going to get cross-reactivity with some of the larger proteins that you might have the same or similarly shaped antibodies. The antibodies are highly specific because, again, we're looking at very small proteins. They are 20 or fewer amino acids. And you're able to measure thousands of peptides in one whole protein for a full spectrum of reactivity. If you think about, there's probably tens of thousands of proteins, tens of thousands of peptides within the whole protein of wheat, for instance. On the wheat zoomer, what's actually being measured is somewhere between 20 and 30,000 peptides. Even though it's reporting 48 markers, we're actually measuring tens of thousands of peptides on that microchip for that particular food. And that's the power of these food zoomers, is we can amplify what we're looking at to such a great degree that we can give you the most accurate description of what you're actually reacting to. So I wanted to put together a different perspective here in case you're a visual learner. What you're looking at on a food sensitivity test. So in blue, I created these little globular immunoglobulin. These represent antibodies essentially. So these are your IgG or IgA. An antibody to that whole protein on the left there would look like this, right? It's going to conform to the shape of the protein. And this is not literal. This is basically just a pictorial description of what's going on. With a food zoomer, what we're testing antibodies to are all of these little individual snippets along that amino acid chain. that has formed those little tiny peptides. So what's being measured on the right is thousands of these for every single food on that food zoomer. What's being measured on the left is 96 of the larger whole protein antibodies that would just be to the whole protein. So hopefully this demonstrates exactly the power of what these food zoomers look at. And this is not specific to any one particular food zoomer. This is all of them. This is what they do. Okay, so I'm going to summarize what we've talked about. IgA and IgG represent sensitivities based on presentation of an antigen, so a foreign protein, to the adaptive immune system. Some IgG antibodies may indicate inflammatory response, while others may be protective. IgA antibodies indicate the immune system's attempt to neutralize a threat, but do not directly generate inflammation. The loss of oral tolerance to a food does not necessarily mean that food can never be consumed again. What you would want to do is assess the severity of reaction and symptoms, the level of antibodies, and the type of antibodies, IgA versus IgG, and decide how long elimination should last. A good deal of that is going to be based on your clinical assessment of the patient, because you are going to have the most information about that patient. And then you always want to retest barrier permeability before reintroducing foods. This step is just critical to a positive experience and a better outcome for your patient. Again, go back and watch the wheat zoomer modules and kind of understand what we mean by retesting barrier permeability, because if we assume that we have healed the gut simply because the patient is asymptomatic, but they're on lots of supplements that may be suppressing inflammatory symptoms, or they've simply just eliminated an inflammatory food, that doesn't guarantee that the antibodies have come down, for instance, on an intestinal permeability panel. The majority of food sensitivity testing on the market is for whole protein extract level antibodies to foods and ingredients. This is limited by the functional digestive status and the intestinal barrier integrity of the patient. Antibodies to whole proteins will not bind to peptides and vice versa, so it's not effective at testing for the minute and individual sensitivities that we form to peptides, which are what are actually presented to our immune system. Rarely will a person's immune system be exposed only to the whole protein form of foods once that food reaches the small intestine. Therefore, peptide level testing provides the most accurate measurement of reactivity to a food based on realistic conditions of digestion. All right, so let's move on to the lectin zoomer. So what's measured on the lectin zoomer? We have over here on the left, the lectin foods that are measured, and on the right, we have the foods that are measured for aquaporin. And we'll talk about a little bit about the difference between lectins and aquaporins in a minute. Actually, right now. Lectins are sugar-binding proteins found in both animals and plants that can bind to carbohydrate structures on cells. That's essentially what they do. Aquaporins are water channels found in cells or the cell membrane in both plants and humans, some of which can cross-react, and the primary symptom that results from this is typically just neurological. Now, there's some controversy over how problematic lectins are. Are they a problem for everyone? Are all lectins a problem? What about how you cook them and prepare them, and et cetera? When you start diving into the literature, the majority of the studies that show cell toxicity in humans on lectins are done using extremely cytotoxic lectins, for instance, from ricin, which are, they're not commonly consumed legumes or grains in the form that they would be consumed, or they're performed using commonly consumed legumes and grains only in animal models, so primarily murine or porcine. So we have, mouse, rats, and pigs. The assumption from these studies is being made that the similarities between the human and the animal model of gut glycosylation, which is that sugar binding action of lectins, is close enough that animal results could be extrapolated to human conclusions. There's some debate as to whether or not that's actually even true as far as gut glycosylation in animals and how that differs in several key ways from humans. Again, and then there's the whole issue that the cytotoxic lectins from foods that humans would not consume, or they would not consume them in that form. For instance, we don't consume raw kidney beans. Raw kidney beans are incredibly cytotoxic. We don't consume them raw. these lectins are problematic for human health, obviously, but they are not in forms that we consume. So a good deal of the argument against lectins is built on those studies. And when you begin to take those studies out, there's few that are left that really show some good data as far as human health. Now, there is a growing body of evidence of using lectins as potential cancer treatment mechanisms, which is actually a positive effect that they may have, simply because they're able to agglutinate cancer cells. So that's something to keep in mind. There are some studies in animals that definitely do show that phytohemagglutinin activity is upregulated from lectins, which essentially causes hyperplasia of the small intestinal mucosa. So that means irritation of those small intestinal mucosal cells. So that's something to keep in mind too, that some animal models definitely do show that there is an inflammatory component here. And again, we don't really know how much of that truly can be extrapolated to humans. Cordain theorized, it's almost been 2 decades now since some of those landmark papers were released from Cordain and Colorado, that the main problem with dietary lectins is they're basically more likely to facilitate translocation of endotoxins from various problematic bacteria residing in the mucosa. And this is probably more a concern than whether or not they have phytohemagglutinin or glutenizing activities, because this facilitation of translocation of endotoxins is probably the most problematic thing about lectins that we have been able to uncover and actually study and prove to date. Again, these studies that have been done on hemagglutinin effects have been done in animals or using raw lectin consumption, and they are therefore not that relevant to humans simply because we don't eat raw lectins, we're not animals, and there's different mechanisms involved. And we typically do cook our lectins. There's a few that we probably don't, and most of them can be pressure cooked and completely reduce the lectin content to amounts that are below toxic levels for humans, or below even inflammatory levels for humans. However, it is important to know that animal studies do show that some lectins are able to bind to epithelial cells. They can cause GI discomfort, which might result in nutrient malabsorption. But there's also some animal studies that have shown that they can affect metabolism of nutrients and actually promote fat loss. There's a body of research going on in lectin utilization in obesity, and they are in animal models, again, being used to yield fat loss. So animal models may be suggestive of inflammation. However, these have not been carried over and performed in human populations yet. So why measure sensitivity to lectins? First of all, on the food zoomers, the lectins are not included in the tests with the exception of the wheat zoomer. So the corn zoomer does not include corn lectin. The peanut zoomer does not include peanut lectin. They're sort of a class of their own. And so we've created an entire test that just groups all of the lectins into one, as well as aquaporins. Another thing to consider too is on those food zoomers, you may have a food zoomer that's non-reactive, completely non-reactive to that food, but that individual may still be reactive to the lectin component of the food, which would then necessitate its elimination, at least temporarily until the intestinal barrier is healed. And so we have here a really good example of a patient. All 3 of these tests were run on the same patient, 13-year-old female. She had a corn zoomer, a food sensitivity, and a lectin zoomer. And you can see that the corn zoomer was actually completely negative. So she had all of the proteins or peptides, peptides present in corn were completely negative. Her food sensitivity was also completely negative. And her lectin zoomer, however, showed antibodies, moderate IgG antibodies, as well as IgA to corn lectin. So if all we had done was run a food sensitivity test on her or a corn zoomer on her, it would have looked like corn was a food that would have been okay. Let's say, especially in a situation where you have a patient that needs to go gluten-free, corn is often a grain that is a fallback for some of these patients. It's commonly consumed because it's a non-gluten containing grain. It's typically seen as safe for gluten-free individuals. And in this case, this patient still needs to be corn-free because she has antibodies to corn lectin. So it's a really good idea to just kind of check the box to look at lectins just in case, especially with patients going gluten-free, because you do have a couple, especially with rice. So again, this patient here also had antibodies to rice lectin, where that would have been a grain that she still would have wanted to eliminate. And she, again, on her food sensitivity on brown rice, did not have antibodies to that. So again, lectin zoomer can certainly be that pivotal tool in your recovery and nutritional intervention protocols for patients. So some conditions that may have association with lectins, again, some of the research is done in animals. Some of it is sort of indirect and tenuous as far as the connections that these have to lectins. There's a lot of it is anecdotal, and more of it is case study based, which case studies, you know, when we put dozens of case studies together, we can certainly start to form some patterns and look at maybe some of these clinical associations. Arthritis, rheumatoid arthritis may have some connections, as well as other connective tissue disorders. Definitely gastrointestinal inflammation. This is certainly an anecdotal or observational report in many, many cases that individuals who cut out lectins see improvement in gastrointestinal inflammation, or particular foods may need to be eliminated that are high in lectin to reduce that inflammation. There might be multiple reasons why that is. It's important to also keep in mind that your higher lectin foods are legumes and grains, and these foods also tend to be high FODMAP foods. So if you have patients with SIBO, those high FODMAP foods are going to definitely irritate the intestinal tract and actually exacerbate the symptoms of SIBO. So there will often be symptom overlap between something like lectin foods and high FODMAP foods. And it's difficult to say that it's only because they're lectins or it's only because they're high FODMAP. So keep that in mind too. We definitely do think that we do see that there's some issues with intestinal permeability and lectins, as again, Cordain's theory being that these basically just facilitate that absorption or easier passage of endotoxin, which that in itself is that sort of subclinical endotoxemia that can be problematic for chronic disease. And then there's also some research that possibly some lectins, and this study that's cited here is specific to peanut, may increase cancer inflammation or exacerbation of cancer in established cancer patients. It really hasn't been established that people who do not have cancer will develop cancer by eating higher lectin foods. So that's just an important point to make. So let's move on to aquaporins. Aquaporins are not lectins at all. They have not really anything to do with lectins. However, they are a water channel on cell membranes, and we've grouped them into this test because they may have similar effects in the body potentially, and simply because they kind of warrant being grouped into this. So these water channels basically control the water content of cells. They allow solutes and fluids to go in and out of the cell in a kind of organized manner. They are distributed widely throughout nature in all living organisms. So plants and animals have these, and they're critical to optimal cellular function. So you can see that if we don't have optimally functioning water channels, these aquaporins on our cells, if perhaps we're making antibodies to them, we could have cell death or destruction or dysfunction that could lead to symptoms of some sort, depending on which cell is being affected. So where we see aquaporins being important to human health or chronic disease is that aquaporins in some foods, so these are your plant aquaporins, have been shown to be structurally analogous to aquaporins in the human body, particularly those in the brain, which are aquaporin 4. When you consume a reactive food and develop antibodies to the aquaporin from that food, there's a high risk for developing autoantibodies to your aquaporin 4 in the brain, which can elicit neurological damage because essentially you're making antibodies to a structure on the cell membranes of your neurons or neurological cells. Aquaporin 4 antibodies are measured on the Neural Zoomer Plus, so that may be a very appropriate test to run alongside a wheat zoomer in patients with established neurological inflammatory symptoms or diseases. So if you are looking at, if you've got a patient coming in that's already presenting with those symptoms, maybe balance problems or memory problems, and you suspect any number of different neurological conditions or inflammation, running a neural zoomer plus with a lectin zoomer is certainly a good combination, because you could have aquaporins as one of the food triggers involved in some of that inflammatory response. So typically the conditions that have association with aquaporins are going to be limited to neurological autoimmunity. That's where the main body of research has focused so far. Specifically neuromyelitis optica. This is what's been the most well studied as far as this aquaporin 4 connection. However, you would have to also understand that in order for this to happen, you have to have some form of blood-brain barrier permeability. So either currently or previously there had been some breach of the blood-brain barrier in order to allow these aquaporins access, or the antibodies to these aquaporins access to the brain. That would precipitate your aquaporin 4 derived autoimmunity. And there's also some connections to peripheral demyelination. So then that may be some of your peripheral neurological autoimmunity or symptoms versus the ones that are more central or optic. And by the way, there are sections on that Neural Zoomer Plus that break down all of those categories: neurological, optical autoimmunity, blood-brain barrier, as well as peripheral demyelination. So what do you do with the results? All right, you've got a lectin zoomer. Where do we start? So in general, this is not even specific to neural zoomer. This is just IgA and IgG. Any IgA antibodies would warrant immediate elimination, regardless of moderate or positive. That's something that we can cut that food out right away. And because IgA has such a short half-life, the half-life of it is 6 to 10 days, those antibodies go down rather rapidly. IgG moderate antibodies should be eliminated in the short term and rotated after 30 to 60 days of elimination. Also, after assessing the status of your intestinal permeability for that patient, you'd want to confirm that the gut barrier is no longer leaky. So whatever protocol or interventions you put that patient on, you would want to retest at a minimum the intestinal permeability for that patient to make sure that there's no zonulin, anti-zonulin, anti-actin, or anti-LPS antibodies, demonstrating that there's still some leaky gut going on, which means that if you were to reintroduce those foods, you would really just start the same cascade of inflammation over again. IgG moderate antibodies to aquaporins specifically in the presence of neurological symptoms or disorders should be a long-term elimination. Those are foods you're not going to re-add back in, because typically you're not going to regain oral tolerance to that while you're trying to undo the damage and inflammation from that. If you've got moderate or positive IgG to aquaporins, also consider running that Neural Zoomer Plus if you haven't already. Get a baseline for those aquaporin 4 antibodies, along with other neurological autoantibodies that may be clinically relevant to that patient. IgG positive results are definitely a longer term elimination. It just takes longer for IgG antibodies to come down. And they should really only be reintroduced after at least 90 days, possibly up to 6 months though, and confirmation of that intact intestinal barrier. Again, retest that intestinal permeability panel at a minimum to look at where those antibodies are. Have they healed? Are they still elevated? Is there still something causing that leaky gut? If so, don't reintroduce those foods. If the inflammatory symptoms or conditions are persisting after elimination of those foods, assess the status of comorbid autoantibodies or inflammatory conditions and make the best clinical decision based on the patient's unique set of circumstances. So there will not be a one-size-fits-all approach. These are kind of just general recommendations, but you may have patients with special circumstances that perhaps need to do further food elimination, or perhaps even if they say they've eliminated the food, they may not have fully cut it out. It's difficult to be 100% lectin-free or 100% wheat-free or dairy-free, etc. So another way to look at this, if you are a little bit of more of a visual learner, you can kind of compartmentalize it this way. So the same information we just covered, if you've got IgA moderate or positive, those would be immediate eliminations. Confirm the intestinal barrier is healed before reintroducing. Down here, in the far left corner, you should see optimal zonulin, antizonulin, and actin, as well as anti-LPS. That one's not as commonly elevated, but again, it should also be optimal. Moderate IgG, positive IgG, and then if you have IgG moderate or positive with neurological disorders or symptoms, check a neural zoomer plus first. Just keep in mind the original neural zoomer does not contain those aquaporin 4 antibodies, only the neural zoomer plus does. And then you would want to take a look at, is there, clinical reason and support for long-term elimination of these foods? Do I see symptoms? Do we have other autoantibodies to the brain or nervous system? And if so, those foods would be gone long-term. All right, so let's move on to dairy zoomer. Dairy zoomer, just like lectin zoomer, we're looking at peptide level assessment. So if you remember, think of that chain of pearls. We're looking at individual little snippets of the entire chain of dairy. So it is specific only to cow's milk. These are just a few things that it's important to know about this test before diving into interpretation. Only to cow's milk. Some proteins in cow's milk are similar enough in molecular structure, or they have enough homology to goat or sheep's milk, that these other milks may be potentially inflammatory in some individuals. Oral challenge of alternative milks might be warranted, but use your best clinical judgment. Meaning that symptoms are not always obvious. Patients may not associate a symptom with something they consumed hours or even days ago. So if somebody is generating an IgG antibody response to a protein in milk, but it's coming 24 to 48 hours after they consume it, they are probably not associating it with milk. And that's important to know. So when you have a patient try a food, a food journal and symptom diary would be a good approach, but they may not always be the best objective measurement for whether or not a food is safe. What we can say is whether or not cow's milk is okay or not okay for a patient. We cannot extrapolate this information, unfortunately, to goat or sheep's milk because these proteins may be so similar in those other milks that they probably would also be inflammatory in that case. So here's another description. We've got food sensitivity testing over here on the left. This is what food sensitivity testing is measuring. It is the extract form of cow's milk. So it includes all of the milk solids as well as the water, any of the carbohydrate structure as well as fat. Those carbohydrate and fat residues may still be kind of hanging on in that extract. And again, that's all food sensitivity testing, not just Vibrant. Then you've got dairy zoomer over here on the right-hand side, where we are breaking down all of these smaller proteins. So casein and lactoglobulin, lactoferrin, those are all smaller proteins. We take all of those, unwind them into their string of pearls, and we look at all the little peptides in every single one of those. So we're talking about, again, tens of thousands of peptides within cow's milk, dairy being measured here. Dairy zoomer is also not a test for lactose intolerance. This is a question that the lab gets asked often by both patients and providers. Lactose intolerance, if you remembered the very first part of this module, we discussed the differences between allergies, sensitivities, and intolerances. Lactose intolerance does not involve any immune reaction whatsoever. There are no antibodies generated. It is not measurable on a test like this, and typically not measurable anyway, because it's actually the lack of lactase enzyme. You could have that tested, but this is not what that test is for. So if somebody says, we've actually been asked this numerous times, patients have contacted the lab and said, I know that I'm lactose intolerant, but this dairy zoomer doesn't show it. I think your test is wrong. That's because this doesn't measure lactose intolerance. So this is not what that is for. This is strictly antibody-based hypersensitivity. Things to know about dairy, we're talking about specifically cow's milk again. Casein and whey are the two main protein families found in milk products from all animals, including humans. The ratio of these proteins will vary by species, but all proteins in milk will generally fall into one of these two families, either casein or whey. Caseins make up the majority of protein solids in cow's milk, with alpha casein and beta casein being the most prevalent. A1 beta casein is the form found in about 90% or more of dairy products in the US. It comes from cows derived from breeds in Northern Europe. And then A2 beta casein, which is what you'll see labeled in grocery stores, sort of a trendy thing lately, is A2 milk, comes from cows derived from stock in Southern Europe. A1 beta casein and A2 beta casein differ by only one amino acid. So it's really important to understand that these two proteins are so incredibly similar that they essentially have the same antibody. Antibodies to A1 casein and antibodies to A2 casein are the same. There may or may not be support for lesser immune reactions seen from A2 cow's milk versus A1 cow's milk, and this will vary by individual, and we'll get into that here in a little bit more detail. Antibodies to beta casein alone do not rule out sensitivity to A2 beta casein. So if your patient's test has positive antibodies to beta casein, it could be either A1 beta casein or A2 beta casein, simply because, again, the protein structure is so similar. There's only one amino acid difference between the two. Where there may be support for substituting A2 cow's milk based on dairy zoomer results is when you see those antibodies to beta casein and antibodies to beta casomorphin. If you see both of those, that is indicative of a specific response to A1 beta casein, but not to A2 beta casein. And we'll talk a little bit more about why that is. We'll get into a little bit of biochemistry there of protein hydrolysis. But just know that if there is only beta casein antibodies and not beta casomorphin, that is specific to both A1 and A2 casein. If you see beta casomorphin antibodies in addition to beta casein, that is specific to A1 beta casein, and A2 cow's milk might be okay for that patient. But again, that's clinical judgment on your part and, trying an oral challenge possibly after an elimination to see how tolerated it is. So here's why this is the case. Beta casomorphin, casein itself is a protein. It's a larger protein within a much larger protein of cow's milk. So casein itself has a portion here where you can see that the difference in A1 and A2 beta casein is the 67th residue of a 209 amino acid beta casein protein chain. So out of 209 amino acids, the only difference is at position 67. There is a histidine instead of a proline, where we're talking about A2. So it's incredibly similar. When we say it is the same antibody, it really is the same antibody. Now, in the case of this protein digestion, if you have A1 milk, because the histidine is in that position, it is easier for enzymes to cleave this, and beta casomorphin is a peptide that breaks off. And that is where, when we see both casein antibodies and beta casomorphin antibodies, we know that that is A1 milk because it had a histidine instead of a proline, and that bond was able to be broken and beta casomorphin was formed. If you have A2 casein milk, you have a proline there, and that cannot be cleaved. That peptide bond between that proline and the next amino acid cannot be broken, and therefore that stays intact. So there would be no antibody to beta casomorphin in that case. So that's why we can only say that someone is not sensitive to A2 milk when there are both beta casein and beta casomorphin antibodies present for this reason. Dairy peptides and inflammatory symptoms and conditions. There's been, decades worth of studies and theories that have floated around as far as how dairy may be inflammatory and the types of things that it may be associated with. There's been a lot of research in animals. Human research has been slow to come. Hopefully with tests like the dairy zoomer, we can get better answers and better clinical studies can be performed. But this is essentially what we do know, that casein and retinal S antigen overlap, which is one of the markers on the dairy zoomer, there is association with uveitis. Basically, uveitis is eye inflammation. If the patient has been diagnosed with that, or they have eye inflammation, or they mention symptoms that might indicate maybe eye inflammation, cow milk should be eliminated long term. Beta casein, of course, we know there's some connection with type 1 diabetes in children. If there's no history of diabetes, still possibly elimination 3 to 6 months, confirm barrier integrity before reintroducing the food. If there's no anti-beta casomorphin, A2 milk may be appropriate after that initial 3 to 6 month elimination. If you have the beta casein and islet cell overlap, again, remember your islet cells in your pancreas are related to diabetes when we make antibodies to those. So this could indicate that there is a dairy trigger in the root cause of diabetes, especially type 1 diabetes. This would be long-term elimination of cow's milk for that individual. Beta casomorphin, we already kind of talked about. If it's present alongside beta casein, this can demonstrate specific sensitivity to A1 beta casein. A2 milk may be tolerated after initial elimination of all cow's milk dairy. Let the immune system calm down, heal and seal the gut, and then retest that gut barrier to confirm that it is actually healed. Another one to keep an eye on, beta-lactoglobulin. This is basically related to a protein made during pregnancy in humans. Glycodelin is the human protein made during pregnancy, has significant homology with beta-lactoglobulin from milk. This could influence autoimmune activity. The connection here as far as cause and effect is not really clear, though. There have not been good, significant human studies that have really sussed this out. And then the last one is butyrophilin. This has actually been observed to have cross-reactivity with myelin oligodendrocyte glycoprotein, which is your anti-MOG that you might see on the neural zoomer plus. And there are some connections between this and multiple sclerosis, as well as possibly autism. This has also been identified as connection with anti-MOG, I mentioned, anti-cerebellum proteins, and then anti-Purkinje cell. So if you are looking at a neural zoomer plus, or if you are running a dairy zoomer on a patient with neurological symptoms, I strongly encourage you to run a neural zoomer plus, because you may be looking at a dairy trigger in the basis of that neurological degeneration or inflammation. And you may be able to implement, a pretty profound dietary change in that individual to help reduce some of the inflammation. And you may also catch some other things as far as neurological degeneration that's going on that neural zoomer plus that you wouldn't have otherwise caught. Similar process here as far as what do you do with the results on a dairy zoomer. Again, you definitely want to retest barrier permeability status before reintroducing any foods. You don't know if the patient has seen symptoms recede simply because they've eliminated the food, or because their gut is actually healing, because they're not necessarily the same thing. IgG positives, you would definitely want to eliminate longer term, up to 6 months potentially, reintroduce once you've confirmed the intestinal barrier is healed. You do want to make sure that, again, if you have other comorbid conditions, so for instance, if you have IgG positive islet cell overlap, you would not reintroduce those foods, even if you did confirm that the intestinal barrier is healed, just because there's such a strong connection to type 1 diabetes in those. And then something else to consider, again, if you have other disorders and symptoms, you'd want to look at things like neural zoomer plus. You might want to look at diabetes as far as testing for patients that maybe haven't yet been diagnosed with that, but maybe are suspected, especially if you're looking at pediatrics. But even into adults, there may be some connections between dairy and pancreatic inflammation. And that is the end of Module 1. Thanks for joining us, and we'll see you in Module 2.